Now let us come to the analysis and design part of the control system. Now what is an analysis? Analysis means that process by which the system performance is determined. And what is design? It is the process by which the system performance is created or changed. Now let us suppose that if the transient response and the steady state error are analyzed and found not to meet specifications, then the parameters needs to change or additional components needs to be added to meet the specifications. So that is the analysis and design part. And also we can say that the control system, the nature of the control system is dynamic. It means that it responds to input by undergoing a transient response before reaching a steady state response that generally resembles the input. So first transient is there, and after that we will have the steady state response. So transient response, first come to transient response. So we have to analyze the system for existing transient response. It is also important. Let us take the case of an elevator. A slow transient response makes the passenger impatient, and whereas the excessively rapid response makes them uncomfortable. And if the elevator oscillates about the arrival floor for more than a second, then the feeling would be very bad. So, or we can say that it is a disconcerting feeling is there. So transient response is also important for the structural reasons, and if too fast a transient response is there, then it could cause a permanent physical damage also. So we have to adjust the parameters or design the components to yield the desired transient response. Now come to the steady state response. That is what remains after the transient decays to zero. It is a steady state response. And in the steady state we are concerned about the accuracy, that when we press the button and we want the lift to be at 4th floor, so we exactly want to be at 4th floor, it should be accurate. And also we can define the steady state error quantitatively by using that is, we can define the steady state response quantitatively by this steady state error. So these two responses are very important from the stability point of view. Now the total response of the system is the sum of natural response and the forced response. So when we study the linear differential equation, these responses are homogeneous in particular solutions. So a natural response actually describes the way the system dissipates or acquires the energy, and it doesn't depend upon the input. On the other hand, the nature of the force response is dependent on the input. So the total response would be the natural response plus the forced response. And for a control system to be useful, the natural response must approaches to zero, and thus leaving only the forced response. So however, in some systems you will see that natural response grows without bound rather than diminished to zero, and sometimes the response is so large that it will be very large as compared to the forced response with the large oscillations, and as a result the system would be unstable. So that thing should be taken into consideration, that stability aspect in terms of the transient and response and the steady state response can be taken into consideration while designing any system. It should be such that it would reach the steady state after certain transients. So you may be confused with the words transient versus natural and steady state versus forced. So the natural and forced responses are the underlying mathematical components of these responses. You will see that the transient and steady state portion are indicated in this graph. That is the graph of an elevator. The transient response is the sum of natural and the forced responses, and while the natural response is large in this case, and the steady state response is also the sum of the natural and forced responses, but the natural response is small in this case. So this response that we are getting is the transient and the steady state response that is there. So these are actually the underlying mathematical components of these responses. Other considerations while designing a control system is the hardware selection. That is size of the motor and the sensors for the greater accuracy of the system. Other consideration is these are the finances that also we have to take into consideration. The last most important consideration is the robust design. So what do you mean by robust? So when we design the system, we actually design the system, and the system parameters are actually constant, and these are constant, and for a transient response, steady state errors and stability when the actual system are built. However, with time the parameters will change, and parameter change is not the linear function of effect on the performance. So it will be a difficult problem. So since a small change in the parameter can lead to a very large change in the performance of the system, so this change would be least and design must be robust.